I'm Anil Kumar, and in this video, I'll discuss at length about Cartesian equations in R2. We also call them scalar equations, right? So that's the other name for Cartesian equations. Cartesian equations can only be written in R2. Okay, connection with intercepts and normal, that's what we will understand from a basic Cartesian equation, which could be written as ax plus by plus c equals to 0. Now let me take up an example to begin with. So let's take up some values. For example, I could write an equation as let's say 2x minus 3y plus 6 equals to 0. You have learned this equation as standard form earlier. We'll call this in vectors as Cartesian equation. If I rearrange this equation, so in first step, what I'm going to do here is I'm going to rearrange it to isolate y. So I could write this as 3y equals to 2x plus 6, or y equals to 2 over 3x plus 6 over 3, which gives us y equals to 2 over 3x plus 2, right? So that is your slope-intercept form. Here, you know, direction, or I should say slope, m is equals to 2 over 3, right? That's the slope we had been talking about. And y-intercept, which is b, is equals to 2. When we compare this with y equals to mx plus b equation which you have learned so far, good? So that is kind of the background which I've given you about the direction and slope from such an equation. Well, if slope is this, then slope of perpendicular line, which I could draw like this, that is slope of perpendicular will be what? Slope of perpendicular will be negative reciprocal, right? So slope of perpendicular will be, we'll flip 2 and 3, we can write this as 3 over 2 and change the sign. Do you see that? So negative 3, 2. So you can see negative 3, 2 here. So that is the kind of relation. Perfect. So that is what we had learned since grade 9 onwards, right? So grade 9 to 12, we learned all this. Now, as soon as we are introduced into vectors, we are calling this as a Cartesian equation. So let's look into this. So what we find here is that basically the normal to the line will be represented by the vector AB. As you can see here, right? If I write normal for this line, then we write this as 2 minus 3, right? 2 minus 3. Do you see that? This kind of correlation. Perfect. And if I have to write x and y intercepts, let me rewrite. If I want to find x-intercept, then I should say y equals to 0. If I substitute y equals to 0, I get ax plus c equals to 0, or x is equals to minus c by a, correct? To find y-intercept, we can say x equals to 0, and then calculate what y is. So that means it is 0 plus by plus c equals to 0. So by equals to minus c, or y is equals to minus c over b, right? So from this Cartesian equation, we can straight away write intercepts also, right? So that is very important. So we can write intercepts as x-intercept will be the point minus c over a 0, and the y-intercept will be minus c over b. Is it okay? So from this kind of an equation, which is in vector form, we can get normal as well as the intercepts, right? Let me take another example of this kind, which is, let us say, we are given that the normal is 2 minus 5, let us say, and the line goes through a point P, which is, let's say, 3, 1. In that case, Cartesian equation can be written as, since normal is 2 minus 5, we could write this as replacing a with 2, b with minus 5. We get 2x minus 5y plus c equals to 0. To find c, substitute 3 and 1. So we get 2 times 3 minus 5 times 1 plus c equals to 0, which is 6 minus 5 plus c equals to 0. 1 plus c equals to 0, c equals to minus 1. And therefore, the equation will be 2x minus 5y minus 1 equal to 0. So if you are given a normal and a point, you can very easily write down Cartesian equation of a line. You'll also notice that this equation is normally unique. In vector and parametric equations, since we were defining with respect to a point, they were not unique. Now, let us look into derivation of this. We just took few examples and kind of vaguely understood what this Cartesian equation is and what A, B, C could be, right? Now we'll talk about developing the formula which we just used for Cartesian equation. So now let us consider that we have a line. So let's say, let me sketch one here. That's the coordinate plane. We are talking about R2 when we talk about Cartesian equation. Okay, let's say the line is kind of like this. So we have a line L here. Now, on this line L, I can draw a perpendicular from the origin. So this is the origin. So if I draw up a perpendicular here, a line this is going right like that as a perpendicular, that means making 90 degrees, that will be called the normal. So from the origin, any perpendicular to the lines, let me write down a line perpendicular from origin to given line is called, we call this as a normal axis. So we are given a line, let's say to the given line L, let's say we call this as L, and that's the line which is perpendicular. Let me call this as N. Okay, so line perpendicular to from origin, this is from origin, let's say N, from origin to the given line L is called normal axis. So any perpendicular line will be called normal axis. Now what you notice here is that we could actually define this line L in terms of the normal. So let us say the vector normal, which is with tail at origin, is represented by AB, let us say, right? So let's say this normal is represented by vector AB, okay? And on the line L, let's take 2 points P and Q. Let's take 2 points P and Q. Let us say that the coordinates of point P are x0, y0, which is fixed, some given point. And this is a general point xy. So what we have here is normal axis, that is the normal axis. Normal axis is always from origin. And we are given point A, let's say point P in our case, x0, y0, and a general point, any point on this line as Q, xy. So xy will represent any general point. So what we know here is we know all these parameters. We know A, we know B, we know x0 and y0. This is known to us. Okay. Now, since this is normal to PQ, the dot product should be 0, correct? So dot product of AB with passing through these 2 points, what is the direction? X minus x0, y minus y0, correct? That should be equal to 0. So now when you do this dot product, you get AX minus AX0, and this is with A, this is the x coordinate, and with B we get plus BY minus BY0 equals to 0. Let's rearrange. We could write this as AX plus BY minus AX0 minus BY0 equals to 0, right? As you can see here, these are known to us. They are constant. A is given to us, B is given to us, and these 2 points are also given to us. So we can replace this by another constant C and rewrite the equation as AX plus BY plus C equals to 0. So that becomes the Cartesian equation for any line whose normal is known to us. Do you see that? So from here, what we conclude is that if we have a line AX plus BY plus C equals to 0, then normal vector to this line is AB, right? Normal vector is AB, correct? Now, you'll also notice that vector of different lengths could be normal to this line, right? So that means we could write n as any scalar multiple of AB, right? And that means there are infinite normals to any line. Do you see that? So that is also one thing which we can conclude. Now in this equation, as you can see, it is in terms of general point x and y. So this equation is actually a unique equation to represent line in vectors. Do you see that? Okay, so with this, we have also derived the formula for Cartesian equation. We'll now work with few examples. Example number 1. Determine Cartesian equation of a line with normal 4, 5 passing through the point -1, 5, correct? So what we are given here is normal, which is 4, 5. So when I write like this, I'm saying that this is kind of like this. I mean, 4, 5 means 4 units, 1, 2, 3, 4, and 5 units, 1, 2, 3, 4, 5. So that becomes the normal vector, right? So that is the normal axis. So this is the normal axis given to us. The point is A, which is we can write like this. So we are just writing coordinate points -1 and 5. Is it okay? So -1, let's say -1, and 5 is same height. That is the point. Now the idea is that this line should be perpendicular to the line passing through this, and that is possible only if I draw a line kind of like that. Do you see that? Do you see? So that is how we can define our line. Perfect. So that is the whole idea. So from this point, which is -1, 5, I can now draw a line, and you can see that this line L is what we are looking into, and the equation of this line L is, since we are given the normal, we can write 4x plus 5y plus c equals to 0. This is because in Cartesian equation, the standard form is ax plus by plus c equals to 0, where the normal vector is AB. Is that okay? Right. So since we are given a point, we'll just substitute this point here. So we get 4 times minus 1 plus 5 times 5 plus c equals to 0, which is minus 4 plus 25 plus c equals to 0. Or this is 21 plus c equals to 0, or c equals to minus 21. I mean, minus 21, right? C equals to minus 21. So that gives you the equation. So our answer is that the line L will be 4x plus 5y minus 21, correct? Equals to 0. So that becomes the equation of the line. Okay, so it's very clear. So let me rewrite this. So the line L is 4x plus 5y minus 21 equals to 0, right? Okay, let's move on to the second question, which is determine Cartesian equation of the line passing through given 2 points. So we're given 2 points. Let's say point A is given to us as minus 3, 5, and point B is given as minus 2, 4. You can actually pause the video, answer the question. What we'll do is we'll first find the direction vector, right? M. So the direction vector for AB is what? It will be minus 2 minus of minus 3 and 4 minus 5, correct? That is to say, it is minus 2 plus 3, which is 1, and 4 minus 5 is minus 1, correct? So the direction vector is 1 minus 1. If that is the direction vector, then what is the normal vector? Normal vector, normal to AB or axis will be, we have to flip this, 1, 1, change one of the signs, so it becomes just 1, 1, correct? If that is the normal vector, then general equation is ax plus by plus c equals to 0. Replacing 1, 1 for a and b, we get x plus y plus c equals to 0. To find c, we can substitute either of these points. Let's substitute minus 2 and 4. So we get minus 2 plus 4 plus c equals to 0. So we get c, this is 2 plus c equals to 0, and that gives you c equals to minus 2. Since c is minus 2, I could write the equation of the line as x plus y minus 2 equals to 0. Correct? So that is how you will get. You can substitute the other point. So what we did here was we used the point B, which is minus 2, 4, correct? What you can do is try it out. So what we're saying is try with A, which is minus 3, 5, and see if you get the same result. Right? Here is question number 3. Determine Cartesian equation of a line perpendicular to 2x minus 4y plus 7 equals to 0 that passes through the point A, which is 7, 2. You can always pause the video and then try out the question. So we are given the line which is 2x minus 4y plus 7 equals to 0. Now for this particular line, what is the normal? The normal vector here is 2 minus 4. Now we want a line which is perpendicular to this line, right? We want a line which is perpendicular to this line. So for that, the normal vector should be what? We have to switch, right? We should 4 and change one of the signs. So 4, 2, correct? Now here, it is a better practice to take out factor of 2, and this is same as 2, 1, correct? Both are same vectors, 4, 2 and 2, 1. So we'll use 2, 1 in our case. Okay. So if 2, 1 is normal for our line, in that case, we could write in Cartesian form like 2x, 1 means plus y, plus c equals to 0. So that makes sense, right? Since we know that point A, which is 7, 2, lies on this line, we can substitute x for 7, y for 2. So we get 2 times 7 plus 2 plus c equals to 0. That gives us 14 plus 2 plus c equals to 0, 16 plus c equals to 0, or c equals to minus 16. Do you see that? So we get c equals to minus 16. Substituting, we get our equation. So the line which is perpendicular to given line should be 2x plus y minus 16 equals to 0. So do you see how we can do it, right? Let's move on to question number 4. Question number 4 is, given lines 2x minus 3y plus 6 equals to 0 and 4x minus 6y plus k equals to 0, explain why the above lines are parallel. That's part A. And part B is, for what value of k will the lines be coincident? That means exactly same lines, correct? Okay. So we are given two lines. Let's say L1 is 2x minus 3y plus 6 equals to 0. And L2 is given to us as 4x minus 6y plus k equals to 0. Right? Now what is the normal vector here? Well, the normal vector here is 2 minus 3. In this line, since 0 is there, what we can do? We can divide everything by 2, for example. But let me first write the normal vector here, which is 4 minus 6, which is also same as 2 minus 3. Do you see that? So both normal vectors are same. Let me call them as n1 and n2. So since n1 is equal to n2, we can say line n1 is parallel to line L2. Does make sense to you? Right? So that's part A of our solution. And in part B, parallel means they could be coincident also, right? Okay. Strictly speaking, coincident will have all points common. Parallel, no points common, correct? Okay. For what value of k will the lines be coincident? Exactly same. So let's write down equation 2 again, which is 4x minus 6y plus k equals to 0. We want the value of k. What we are given is L1, which is 2x minus 3y plus 6 equals to 0. I could multiply this by 2, right? Everything I could multiply by 2 in this equation. If I do that, what do I get? 2 times 2 is 4x minus 6y plus 12 equals to 0. Now if you compare, what do you notice? Well, we have 4x is same, 6y minus 6y is same. So what should be k? K should be equal to 12, right? So for coincident lines, so these are overlapping, right? K should be equal to 12. Do you see that? So strictly speaking, we should say the above lines are parallel where k is not equal to 12. If k is equal to 12, then they are coincident, right? So that is how you could answer the question. Question number 5. Write Cartesian form of following equations. So we'll work with two different types of equations. One you have been studying so far from grade 9 onwards, slope-intercept form. The other, which you learned in vectors, which is called symmetric form. To write Cartesian form, we have to only rearrange it. So multiplying by 5, so what we'll do times 5. We'll do the whole equation times 5. What do you get? We get 5y equals to 2x minus 15, right? Now next step is rearrange. So we get 0 equals to 2x minus 5y minus 15, correct? So that becomes the Cartesian equation where normal vector will be 2 minus 5. You see that? So that becomes the Cartesian equation. Let me rewrite this as 2x minus 5y minus 15 equals to 0. Got it? If you are given equation in symmetric form, the best way is just cross multiply. So you could write this as 5 times x minus 1 equals to 2 times y plus 4. 5x minus 5 equals to 2y plus 8. Bring them together. 5x minus 2y minus 5 minus 8 equals to 0. So we got 5x minus 2y minus 13 equals to 0. So that becomes the Cartesian equation. Do you see that? So simple steps. You can easily convert any form of line into Cartesian form. Okay. So question for you is, use this equation R, which is in vector form. Let's say we have 3, 2 plus t times 1, 3. Okay. Write this in Cartesian form. Let this be the exercise for you. Question number 6. Find the angle between pair of lines. So we give 2 lines both in Cartesian form. So what we can say here is that the angle between lines is same as angle between their normals, correct? Normals. And the lines will give you the same angle. So that is the concept. So we are using this concept to find angle between a pair of lines. So the first equation is x minus 3y plus 6 equals to 0. That gives us normal as 1 minus 3, right? The second equation is x plus 2y minus 7 equals to 0. That gives us, let's say, n1 and n2. The normal 2 is 1 and 2. How do you find angle between lines? We'll use dot product, correct? So we'll use dot product. Let me write down the basic equations on the right side and then we'll just use them. So what is n1 dot n2 equals to? Magnitude of n1, right? These are vectors, times magnitude of n2 cos theta, correct? So we can find cos theta as equal to n1 dot n2 divided by the magnitudes of these normals, correct? Then theta cos inverse will give you the angle, right? Okay, so let's do it. So using this concept, we know cos theta will be equal to n1 dot n2. n1 is 1 minus 3 dot, n2 is 1, 2. Magnitude is 1 square plus minus 3 square times 1 square plus 2 square, correct? Now that gives you 1 times 1 is 1, minus 3 times 2 is minus 6 over, this is square root of 1 plus 9, which is 10. That is square root of 1 plus 4, which is 5. So what we get here is minus 5 over square root of 50, or you could write this as 5 square root 2, right? So 5 and 5 cancel, get minus 1 over square root 2. So you could use calculator, find the answer. However, since we know cos is negative, that means we are looking for a solution which is somewhere here, right? And that is a special triangle. So we can say from that theta should be equals to cos inverse of minus 1 over square root 2, which is 135 degrees, right? 135 degrees, correct? So that becomes the angle between these two lines. Now it is important to understand that if we have two lines, right? If we have two lines, let's say these are my two lines. So if we say that angle is 135, then that is the obtuse angle, correct? You could also find the acute angle as 180 degrees minus 135 degrees. Does it make sense to you, right? So that is 45 degrees. So the acute angle is 45 degrees. correct? So that is the obtuse angle, and this is the acute angle. So sometimes you may be asked to find the acute angle. So, or, it may be specified. But anyway, you understand the concept, use dot product and get your answer, right? So let's move on. Here is question number 7 for us. The lines x minus y plus 1 equals to 0 and x plus ky minus 3 equals to 0 have an angle of 60 degrees between them. For what value of k is this true? So we'll use the previous formula, which is cos theta equals to n1 dot n2 divided by the magnitudes of n1 and n2, correct? Now in our case, theta is equal to 60 degrees, right? n1 is 1 minus 1 and n2 is 1k, 1 and k, right? n1 and 2. So we can say cos of 60 degrees equals to 1 minus 1 dot 1k over, this is 1 plus 1, let me write down like this, and this is 1 plus k square, is it okay? Squares of these. Now what is cos of 60 degrees? You could always sketch your special triangle in that, it is 1, 2 square root 3, that is 60 degrees, correct? So for 60 degrees, cos 60 is half. So half is equal to 1 times 1 is 1 minus k over, this is square root of 2, and that is square root of 1 plus k square, correct? Now we could cross multiply, so we get square root 2, you could actually cancel this also. This goes square root 2 times. Do you see that? It becomes simpler. So when you cross multiply, you get square root of 1 plus k square equals to square root 2 times 1 minus k. Does it make sense to you? Right? Okay. Now we can square both sides. So what we'll do here is we'll square both sides. So if I square both sides, I get 1 plus k square equals 2. Here square root 2 becomes 2, and that square is 1 minus 2ab, which is 2k plus k square, right? Let's solve this equation on the right side. So we have 1 plus k square equals to, let's open this bracket. So we get 2 minus 4k plus 2k square. Bringing all terms together, 0 equals to 2, let's write down 2k square minus 4k plus 2 minus 1 minus k square, right? So 0 equals to 2k square minus k square is k square minus 4k, 2 minus 1 is plus 1. Now we can actually find the value of k using quadratic formula. So k will be minus of this, which is 4, plus minus b square, which is 16 minus 4ac, so 4 times 1 divided by 2a, which is 2, right? So I hope you remember this formula. We are using the formula, which is let me write down here. If the equation is ax square plus bx plus c equals to 0, then means x is equals to minus b plus minus b square minus 4ac divided by 2a, right? So a, b, c are the coefficients. In this case, 1 minus 4 and 1 are a, b, c's, correct? So let's simplify this, which is 4 plus minus 16 minus 4 is 12 divided by 2, which is 4 plus minus 4 times 3. So you could write this as 2 square root 3 by 2. So the value of k will be 2 plus minus square root 3. Do you see that? So that is how we can get the value of k in the given question. So for an angle of 60 degrees, value of k should be 2 plus minus square root 3. This is a very important question. You should go through it once again, try to understand what we did. We are now at the end. Here is the last question of this video, question number 8. Write Cartesian equation of a vertical and a horizontal line passing through the point P 3, 4, 3 minus 4, right? So what you can do is you can kind of sketch the lines and then write down the equation. You can also pause the video, answer the question, and then look into my solution. Point is 3 minus 4. Let's say 1, 2, 3, 1, 2, 3, 4. So that's the point, right? 3 minus 4. We want a vertical line. So vertical line means like this. Going through this, let's say this is the vertical line. Since it passes through 3, 4, the x-intercept here is 3. It does not have any y-intercept. So normally, you know the equation of the line should be what? At every point, x is equals to 3, right? That is what you expect. Anyway, let's see how to write Cartesian equation. So we know Cartesian equation in general is ax plus by plus c equals to 0. And for a vertical line, what is the normal? Well, if the line is vertical, what is the normal? Normal will be this, right? That is the normal. That is to say 1, 0 is the normal. Perfect. So if I substitute a and b as 1 and 0, I get x plus 0 plus c equals to 0. And since we are given it passes through a point 3 minus 4, I need to substitute this for x and y. Y is already 0, the coefficient is 0. So we are left with x as 3 plus c equals to 0, or c equals to minus 3. And therefore, we can write this equation as x minus 3 equals to 0, or you can also say x equals to 3. So you get the same equation. Do you see that? Okay. Now let's consider the horizontal line. So we've done part 1. Horizontal will be like this. Is it okay? So in the horizontal line, what is going to be the normal? Well, the normal is kind of like this. Is it okay? So that is the normal for us. So for horizontal line, normal will be, so normal you can draw like this or this, one and the same thing. Anyway, we'll write 0 minus 1 and see what the result could be. Is it okay? Fine. So from 0 it is this. Now equation is same, and since 0 minus 1, so we could write this as 0 minus y plus c equals to 0, and the point is 3 minus 4. So if I write 3, it's 0 here, minus 4 here, so I get minus of minus 4 plus c equals to 0. So c is equals to minus 4. Do you see that? So if c is minus 4, I could write this equation as, let's rewrite on the right side. We'll do it on the right side. Okay. So c is minus 4. So I'm writing from here this equation, which is minus y, and c is minus 4. So we get minus 4 equals to 0. So that becomes the equation, or rearrange, we get y equals to minus 4. Do you see that? So y equals to minus 4 becomes the horizontal line, as you would expect. Perfect. So that is how you could do vertical and horizontal line in Cartesian form, correct? So our answers in Cartesian form, actually I should write this as x minus 3 equals to 0. So our two answers are x minus 3 equals to 0, and the other line is, you could make them both positive, right? Y plus 4 equals to 0. So that is a set of vertical and horizontal line through the given point. With that, we conclude our understanding of Cartesian equations, a bit review with few questions. I hope that helps. Feel free to write comments, share your views, and post questions. Share my videos with all your friends and subscribe if you like. Thank you and all the best.